The sixth step in graphing rational functions is to find horizontal asymptotes. These are imaginary horizontal lines. You draw them with a dotted line, and your graph will get very, very close to these values. Your graph might actually touch or cross these horizontal asymptotes. Remember that vertical asymptotes are similar to these, but your graph can absolutely not touch or cross vertical asymptotes. For horizontal asymptotes, these are dependent on the degrees of your numerator and your denominators. So notice my rational function down below. If I look at the numerator, I have highest degree of 2 in the numerator. Notice in the denominator, I also have highest power of 2. So depending on what kind of rational function I've been given, I want to look at those highest powers in the top and the bottom. We have 3 different situations, but any individual function can only follow one of these situations. The first situation is if the degree of the denominator is larger than the degree of the numerator, you automatically have a horizontal asymptote at y equals 0. You don't have to do any kind of work in that particular problem. Look at the example that we have down below. Is the degree of the denominator larger than the degree of the numerator? No. All right, look at part B. If the degree of the numerator equals the degree of the denominator, then you have a horizontal asymptote at y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. Remember that the leading coefficient is the coefficient off of the leading term. Look at the example that we have below. We have highest power of x in the top being 2, highest power of x in the bottom being 2, so notice that the degree of the numerator equals the degree of the denominator. The leading terms are the front 2 terms having the highest power. The understood coefficients on this particular example are 1s. So this particular example has a horizontal asymptote at y equals 1 over 1, or just y equals 1. The third situation that you may run into is if the degree of the numerator is larger than the degree of the denominator. If that's the case, you have no horizontal asymptote, but there will be later on what we call an oblique asymptote. We're going to see this in step 7. But for our example, we noticed that it fit the B situation, and then that yielded our horizontal asymptote of y equals to 1. This would be graphed using a dotted line, making sure that we went through y is 1 on the y-axis.